Hello everyone, we're back with another paper today. Today we're solving this physics paper. This is physics paper 1 multiple choice 9702 paper 11 from the May June 2024 series. The time is 1 hour 15 minutes. I'm going to be uploading paper 1-3 tomorrow as well. And then I'll be rolling out more chemistry, biology and math papers. Before we start, I have some good news to share with you guys. We're actually launching the first physical location for CIA paper solved this February for candidates for the May June 2025 session. So essentially, we'll be launching two batches, one for mocks and one for revision batches, where we discuss question papers and problems, general problems. For A2, it's 3 classes a week, and for AS, it's 2 classes a week. The rates are given below. These are inclusive of tax. And if you have batches of 4 people joining together, you get discounts. So yeah, if you want to join, please do register. The revision batch is a monthly payment, while the one for mock exams is the one-time payment of 80 USD or 9,500 BDT for 3 months of exams and solution classes. Recordings will be provided if you can't attend. And yeah, that's it. So if you're interested, please do sign up. I'll contact you. If you're from Bangladesh, you can give the exams or join the revision batch physically. And if you're an international student, you can join online. I'm gonna have a separate batch for international students. The timings haven't been decided yet, but it will be decided, and more details will be dropped in another video the end of this month. Anyway, let's start. So let's take a look at the threshold before we begin. This is component 1-1. So it was a relatively easy paper since 32 was A. So let's write this down. So out of 40, as you can see, A was at 32, B was at 29, C was at 26, D was at 22, and E was at 18. So relatively easy paper. There's a gap of 3 marks, so A star should be around 35-ish. Okay, let's start. Which unit is an SI base unit? So clearly the answer is going to be amperes, because it is an SI base unit. We know that there are 7 and one of them is ampere. Which of the following could have the same units as force? So we know that F is equal to ma, which is kg ms minus 2. We are looking for this. Okay, so let's try energy. We know that energy or work done is force into distance, and we have distance down below, so we end up with force again. So the answer is A. There's no point in checking the other ones. Number 3, the velocity of an object changes from an initial velocity u to a final velocity v. The vectors represent these velocities. Okay, which single vector represents the change in velocity from u to v? So initially it's u, but then it changes to v. So basically, what is the idea? What is the idea? Actually, it's like this. It's initially u, and then a change occurs, which results in the velocity turning to v. Okay. So the end product is this, basically. This is the end product. This is the end product of the object. So it is initially u, and then a certain change occurs, which results it in being going vertically downwards. So you could check like this. Honestly, the way to do this math was like, you are u at first, then you can try out A. I tried A, I applied A, but look, my final velocity is not vertically downwards, so it's false. Okay, A is wrong. Then this one, if you apply B, it's not vertically downwards. Okay, now apply C. I'll tell you why C is the correct answer, because if you apply C, then look, the final velocity is vertically downwards, just like this, which is why C is your answer. Now 4, an object is moving with initial velocity u. The object then moves with uniform acceleration a for time t until it reaches final velocity v. Which equation describes the motion of the object? Okay, so final velocity v is equal to, it has u at first, and then moves at acceleration a for time t seconds. So this is a simple equation of motion. it should be something along the lines of this: v is equal to u plus 80. So let's rearrange this one. This is clearly wrong because it's 280. Let's rearrange this. U is equal to v minus 80. So v is equal to u plus 80. This looks good. Okay, so b is the answer. They just rearranged it. Number 5, which calculation provides a vector quantity ampere second? Q is equal to IT. This is not a vector quantity. Final displacement minus initial displacement. Displacement is a vector quantity, so yeah, B is correct. A thermometer can read to an accuracy of 0.5 degrees Celsius. This thermometer is used to measure temperature rise from 40 to 100. What is the percentage uncertainty in the measurement of the temperature rise? So it records the reading twice. Okay, it records the reading twice. So the uncertainty will be considered twice. And the change is 60. The temperature rise is 60 and the uncertainty will be considered twice. So 0.5 plus 0.5 is 1. So logically it should be this: 1 by 60 into 100%, which is 1.67%. So rounded off, that is D, 1.7%. The diagram shows the path of a golf ball. Which row describes changes in the horizontal and vertical components of the golf's velocity when air resistance is ignored? Okay, so the horizontal velocity will always be constant since there is no air resistance. Okay, so it has to be between C and D. And vertically, it always has gravity acting downwards, so there will be constant acceleration downwards all the time. It will never change. 7 is C. 8, an aircraft flies from London to Sydney in a time of 21 hours 40 minutes. The total distance traveled is this. What is the average speed? Average speed is equal to total distance divided by time. So let's convert it to meters. Total distance divided by time. Let's convert this to seconds. 21 into 21 hours 40 minutes. So 21 into 60. Let's do that first. 21 into 60. That's 1260 minutes plus 40 minutes plus 40 minutes. That's 1300 minutes. So 1300 minutes into 60 is seconds. So 17k times 10 to the power 3 divided by 1300 into 60. That gives you 217.95 meters. Okay, I convert to meters per second. Okay, so clearly it's not this, right? So let's check the other ones whether these are right. So this is micrometer. If you want to convert it to meters, what do you need to do? Into 10 to the power minus 6. So 2.2 into 10 to the power 7 into 10 to the power minus 6. That gives you a value of 22 meters per second. Still wrong. Let's try this. Nano, that's 10 to the power minus 9. So 2.2 into 10 to the power 11 into 10 to the power minus 9, which is 220 meters per second. And yeah, this is approximately 220 meters per second. So yeah, we're gonna go with C. 8 is C. That's correct. A golf club hits a golf ball. The graph shows the force F, how the force F on the ball varies with time. Which graph shows the velocity of the ball, how the velocity of the ball varies with time? So this is the golf ball and this is the club, for example. So when it hits the ball, at the initial point there is less contact, so there's less force. At the midpoint there is maximum contact, so the force is the highest, and then when it loses contact, the force slowly decreases. So clearly the velocity has to start from 0. Okay, the velocity has to start from 0, so C is wrong. And over time the velocity will actually increase. So D is completely wrong because it shows that it increases and then the velocity becomes negative. That's not possible because the golf ball will go forward. This graph is showing that the golf ball goes forward and then comes backward, which is impossible. So it's between A and B. Okay, it's between A and B. So the gradient of the velocity time graph is actually acceleration. and we know that F is equal to ma. So where is force highest? Or think about this. Let's look at the gradient of this graph. What happens? Over time, between A and B, like which is the correct answer, both of them show a steady increase, right? But it turns out that at this point, initially look like at B, in the initial and final stages, what happens to velocity? The gradient becomes 0. So that states that acceleration should be 0 and force should be 0 at these 2 points, which is kind of true. Okay, which is kind of true, that these 2 points, at these 2 points the force is 0, and which is why the answer is B. Okay, because look, in part A, what's wrong is that at time 0 they're showing that there is a gradient, so there should be an acceleration, so there should be force, but at time 0 we know that the force is 0, which is exactly why B is the correct answer, because it shows that at time 0 and at the end time the gradient is 0, so that means that force is also 0. Okay, what is meant by the mass and by the weight of an object on Earth? So mass is inertia, the property to resist motion or acceleration, D. And what about weight? The weight of an object is the pull of the earth on an object. Okay, is the pull of the earth on an object. These are like definitions, you need to memorize them. Moving on to question 11. A thin horizontal plate of area 0.036 meter square is beneath the surface of a liquid of density 930 kilograms per meter cube. The force on one side of the plate due to the pressure of the liquid is this. Where is the depth of the plate beneath the surface of the liquid? Okay. So we have this plate of area this. So beneath the surface of a liquid of density this. One side of the plate is actually 290 newtons. Where's the depth of the plate beneath the surface? So we are looking for this depth. We know that pressure is equal to H rho G. Okay. We are looking for H, P by rho G. We also know that force is equal to, or pressure is equal to, force by area. So pressure, we can find out the pressure, 290 divided by 0.036. 290 by 0.036, which is 8055. Now we can find out height, the depth. 8055 divided by 930 into 9.81. Let's do that. 930 into 9.81, which gives us a value of 0.883. 0.883. So yes, 11 is A. 12. Spheres X and Y form an isolated system. The mass of Y is greater than the mass of X. Y is initially stationary. Sphere X collides elastically with Y. The mass is greater. Sphere X collides elastically, so momentum will be conserved and kinetic energy will also be conserved. The speed of sphere X before the collision is u. Which statement must be correct? So suppose this is like 5 kg and this is 10 kg. Okay. Sphere X rebounds with a speed that is greater than u, and sphere Y moves off with a speed that is less than u. That is impossible. That's actually impossible because it's an elastic collision. Sphere X rebounds with a speed that is less than u, and sphere Y moves off with a speed that is also less than u. This looks correct. Because to be an elastic collision, the relative speed of approach must be equal to the relative speed of separation. So check this. Since it collides with u, let me move this. So after rebound, so the relative speed of approach is u, so it has to be u here as well. So look at the first statement. Why is it wrong? They say that moves with a speed that is greater than u, which is u plus 2, and y moves up with a speed that is less than u, which might be u minus 2. Now if you do add this up, yes, the value does look u plus 2 plus u minus 2. What happened? You end up with 2u. So the relative speed of approach is not equal to the relative speed of separation. That's why it's wrong. Okay. And instead of u, let's use another value. Like let's use maybe 2 meters per second. I think that should be adequate. So if you apply this with a speed greater than u, maybe that's like 3 meters per second, and moves off with a speed that is less than u, maybe that's 1. Okay. So look, if you add 3 plus 1, it will always be like, even if you use a very small value, like if it increased to like 2.1 maybe, and if it's like 0.2, 2.1 plus 0.2 is still 2.3, and which is not equal to 2. That is why it's wrong. So let's go to the next statement. X rebounds with a speed that is less than u, okay, and y moves up with a speed which is also less than u. Okay, so if it's this less than u, which is less than 2, maybe it's 1.5 meters per second, and this maybe moves up with 0.5. This is the only logical scenario when if you add the relative speed of separation, it equals to 2, which is why 12b is the correct answer. And this is impossible. Remaining stationary is impossible for an elastic collision. A ball of mass 0.1 is thrown towards a stationary vertical bat. The ball hits the bat with a horizontal velocity of 20 meters per second. The ball rebounds and leaves the bat with a horizontal velocity of 15. What is the change in momentum of the ball? Okay. Fine. So change in momentum. Final minus initial. Final minus initial. Minus 0.1 into 15 minus 0.1 into 20. So the change is actually minus 3.5, which is Newton. So you have to subtract all. You just need to add them basically. An isolated object of negligible weight is acted out by two coplanar forces of the same magnitude. In which object is it in equilibrium? Net force has to be 0. Net momentum has to be 0. Here net force is 0. But in these ones, the net force is not 0. It's between A and B, but look. This provides anticlockwise moment. This also provides anticlockwise moment. So this does not have 0 net moment. That's why A is the answer. This provides anticlockwise moment. This provides clockwise moment, and it cancels out. Net force is 0. Net moment is also 0. 15. A uniform beam PQ rests horizontally on a support at point S. A rope is attached to one end. It's at an angle of 60 degrees to the vertical and exerts a force F. What is the moment in Newton meter of the force F about the point S? Okay, you cannot take this component. You have to take this component. Okay, and it clearly has a weight. Okay, so how much is this distance? 2.2 meters, and this is going to be F cos 60. Yeah, oh, it's in terms of F. Sorry, I was trying to figure it out. So it's basically F cos 60 times 2.2. Let's try doing this. Make sure calculator is in degrees. Cos 60 into 2.2, which is 1.1 F. Okay. The diagram shows the dimensions of an elastic cord used to project a stone. The tension in the cord is T when the cord is pulled into the shape shown. Which force does the elastic cord exert on the stone? Okay, so these cancel out. Okay, this is 8, we can find out this angle. How? Sine theta equals to 8 by 10. Let's find it out. Okay, can we just not keep it like this? Okay, so theta, this is 8, this is 10, so what will the other one be? 10 square minus 8 square, root over answer, which is 6. Okay, this is 6. Oh, we have that. So we can just easily go for this is essentially t cos, I'm taking the horizontal component, t cos 6 times 2, t cos theta, sorry, t cos theta times 2. Now what about cos theta? Cos theta is adjacent by hypotenuse, which is 6 by 10 times 2. So 6 by 10 times 2, which is 1.2, 1.2 t, or 12 by 10. If you simplify this, it's 6 by 5, 6 by 5 t. This is the one I'm looking for, and 16 is b. Do you guys get it? Because there are two components, two t's, and we are taking the horizontal component, the vertical one is getting cancelled out. Next, a box of weight 40 newton is pushed with a horizontal force of 20 along level ground for a distance of 2.4 meters. The box is then lifted at constant velocity through a height of 1.6 by vertical force. Total work done by the two forces. Okay, total work done. Work done is the force applied and distance moved in that direction. So in the horizontal one, it's 20 times 2.4, and in the vertical one, it's mgh. So we know that the weight of the object is 40 and the vertical distance is 1.6. So simply add this up. 40 times 1.6 plus 20 times 2.4, which is 112. I'm looking for 112, which is rounded off to 110. So 17 is B. Which statement about efficiency is correct? Efficiency does not have a unit. This is true because it's the useful power output or energy output divided by the total input. So the units actually cancel out. 19. A plane wave of amplitude A is we're starting waves is incident on a surface area of S placed so that it is perpendicular to the direction of the travel of the wave. The energy per unit time reaching the surface is E. The amplitude of the wave is increased to 2A and the surface area is raised to half S. How much energy per unit time reaches this smaller surface? Okay, so we know that intensity is proportional to amplitude square. So if you actually double the amplitude, so the intensity becomes 4 times. Okay, the intensity becomes 4 times. Energy per unit time is basically intensity. Power basically, it's the intensity. Okay, so it becomes 4 times due to the increased amplitude, but the area has reduced to half. So even though the amplitude has, or the intensity has increased by 4 times due to the increased amplitude, due to half the area, we are going to get half of this. So we are going to get half of this because it's proportional to area. So we actually end up with 2A, 2E basically. It's going to be twice the original one. So 19 is B. So hopefully you guys get it. I'm going to repeat again. So due to the amplitude being doubled, the intensity has become 4 times the original, which is 4E. Energy per time is 4E. But due to the area being halved, the area has decreased by half again. Okay, that is the general idea. So 19 is B. Moving on to 20. A steel ball is falling at constant speed in oil. Which graph shows the variation with time of the gravitational potential energy and the kinetic energy of the ball? So constant speed. So the kinetic energy does not change. That's why C and D are wrong. Now GP will decrease. So it's between A and B. But B is the correct answer because it is moving at constant speed down. So it will not be a curve. It is not accelerating or decelerating. It's moving at constant speed, falling down constant speed. So 20 is B. When a force of 0.80 Newton is applied to a spring, the length of the spring is this. When a force of this is applied to the same spring, the length is 115. The spring obeys Hooke's law. What is the spring constant? Okay, let's try doing this. So at 0.80 the length is actually 90. This is in millimeters. And at 1.30 it is actually 115. So the tricky part here is we have to use extension. Okay, so look at the extension as you've increased the force. When you increase the force by 0.50 Newton, the extension increases by 25 millimeter. And we know that F is equal to kx and k is equal to F by x, del F by del x. So 0.50 divided by 25 into 10 to the minus 3. Okay, so this should be it. I'm getting a value of 20. 21 should be 20. That is D, correct. 22. An experiment is carried out using a metal wire to investigate how it responds to varying tensile force. The cross-section area of the wire is constant, which graph has a gradient that is equal to the Young modulus of the metal. So we know that Young modulus is equal to stress by strain. So the correct answer is C. For a wire hook size obeyed for tension F and extension X, the Young modulus for the material of the wire is E, which expression represents the elastic potential energy stored in the wire. So it's either half Fx, okay, or half Kx square. We are looking for this. So half Fx is the area energy stored in the wire. It's the area under the Fx graph. So it's a triangle. Next, 24. Plane polarized wave has amplitude A. The wave is incident normally on a polarizing filter. The transmission axis of the filter is at an angle theta to the plane of polarization to the incident wave. So this is Malus law, right? What is the amplitude of the wave that emerges from the filter? So according to Malus law, the new amplitude will actually be proportional to actually it's not related to amplitude. Essentially the idea is the new intensity will actually be proportional to I naught cos square theta. Okay, so now the general idea is we gotta convert this intensity to amplitude. How? We know that intensity is proportional to amplitude square, so this acts like a middleman. Okay, so we can write this amplitude square, the new amplitude square is proportional to original amplitude square times cos square theta. Okay, so this is the general idea. Okay, so now if they just want to know what is the final amplitude that emerges from the filter, so if you want the final amplitude, what do you need to do? You just need to root over this to get the final amplitude, which is A naught times cos theta. This should be your answer as for the final amplitude. Okay, so 24 is A. If it was final intensity, the answer should have been I naught cos square theta. Okay, 25. An electromagnetic wave is traveling through a vacuum. What could be the wavelength and period of the electromagnetic wave? Okay, so we know that it's G X U V I M R. So visible light is 10 to the power minus 7. So as you go to the right, wavelength actually increases. This is like 10 power minus 5, minus 3, minus 1 and above. This is minus 8, minus 9-ish, minus 9, minus 10-ish. Okay, this is minus 11, minus 12-ish. Okay. So the general idea is, let's match. Okay, it's trial and error. Let's go for A. Wavelength and period. So we know that the speed will be fixed. This is the speed. This is the speed. So we know that V is equal to F lambda and time period is equal to 1 by frequency. So let's check this. So for the first one, 3 into 10 power 8 is equal to wavelength 1.2 into 10 power minus 10 times F. 3 into 10 power 8. Oh, it's terameters, right? So what do we need to do? Multiply it by 10 to the power 12 if lambda. Okay, 3 into 10 power divided by 1.2 into 10 to the power minus 10 into 10 to the power 12. So frequency is 2.5, 1, 2, 3, 4, 5, 6 into 10 to the power 6. Now about the period, t will be 1 by f, so just divide this 1 divided by answer. There's actually 4 into 10 power minus 7 seconds. If you multiply by 10 power 6 into 10 to the power 6, that's actually 0.4 megaseconds. So this is wrong. A is wrong. Let's go for B. 3 into 10 power 8 is equal to 1.2 into 10 power minus 12 times f. Pico is minus 12. 3 into 10 to the power 8 divided by 1.2 into 10 to the power minus 12. Okay. So frequency is actually 2.5 into 10 power 20. So time period will be 1 divided by answer, which is 4 into 10 to the power minus 21, and it's in giga seconds. So into 10 to the power minus 9. Sorry. Yeah. Into 10 power minus 9. So that's 4 into 10 power minus 30 gigaseconds. That's bad. Okay, so let's try C because these are wrong. Triannular sums are usually C or D, the answers. That's just a trick I'm going to tell you guys. Okay, now for C. 1.2 into 10 power to 3 into 10 to the power 8 is equal to this into 10 to the power minus 12 times frequency. So let's do this. 1.2 into 10 square into 10 to the power minus 12. Did I do the previous one correctly? I'm just wondering. Okay, so frequency is 2.5 into 10 power 18. So let's try the time period now. 1 by f, which is 4 into 10 to the power minus 19 seconds. Now to convert it to nanoseconds, what do you need to do? Into 10 power plus 9. So t actually is 4 into 10 power minus 10 nanoseconds, which is correct. So C is the correct answer. There's no use doing 9. Sorry, D. 26. Light of frequency, this in a vacuum is incident normal on a diffraction grating, which contains this number of lines per meter. What is the angle between the second and third order? So it's a diffraction grating, so it will be d sine theta is equal to n lambda. Okay, we have to find out d. So d is equal to 1 by n, so d will basically be 1 divided by 4 into 10 power 5. So 1 by 4 into 10 power 5 into sine theta is equal to, for the second order, 2 times lambda. Oh my god, it's so long. Lambda, we have to find out lambda because we have frequency. So lambda will actually be speed of light, 3 into 10 power 8 divided by frequency, which is 6.7 into 10 to the power 14. V by f is equal to lambda. Let's do this. Okay, so 2 into 3 into 10 to the power 8 divided by 6.7 into 10 to the power 14 into 4 into 10 to the power 5, then sine inverse answer. So theta is equal to 21 degrees for the second order. Now for the third order, 1 by 4 into 10 power 5 into sine theta equals to 3 into 3 into 10 power 8 by 6.7 into 10 to the power 14. So let's do this. 3 into 3 into 10 to the power 8 divided by 6.7 into 10 to the power 14 into 4 into 10 to the power 5, cross multiplication, sine inverse answer. So theta is 32.5 degree for the third order. So it's 32.5 minus 21 degrees, and we get 11.5 degrees, which is rounded off to 12 degrees. Now we go for Doppler effect. The siren of a moving police car emits a sound wave with frequency 440 Hz. A station observer hears sound of frequency. This is the observed one, observed. And the speed of sound in air is 340. What could be the distance and the direction? So basically it went from 440, source increased, so it's moving towards the observer. Okay, moving towards the observer. And now let's find out. Observed frequency is equal to initial frequency, frequency of source, times the velocity of the sound wave or the wave. And since it's increasing, it's going to be velocity of the sound wave minus velocity of source. So observed 494 is equal to source 440 into velocity of the sound, which is 340 divided by 340 minus the movement of the vehicle. Okay, so let's do this. 440 into 340 divided by 494. Okay, and then 340 minus answer, that gives you a value. If you do the algebra, it's 37.2. so 37 minutes per second towards the observer, because the value has increased. That's the logic. The diagram shows the shape at one instant in time of part of a stretched string as a wave travels along it from left to right. What are the directions of the velocities of points 1, 2, and 3 on the string at an instant in time? Okay, so how to do this? This is actually, there's actually a trick for doing this. So it's a string, so it's a transverse wave. You have to draw the wave just a bit after, and then you'll realize, okay, what's happening. So this is the motion of the wave just 1 millisecond after. So look, what is the new position of point 1? It goes downward. What about point 2? It goes upward. What about point 3? It goes down. So it is not horizontal, because we know that in transverse wave, energy is transmitted to the right and the particles move up and down. So clearly from this we can see that 1 is moving down, 2 is moving up, and 3 is moving down. So that's the correct way to do it. Okay, which wave cannot be a longitudinal wave? Okay, so longitudinal waves cannot be polarized. Polarization is a property of transverse waves. 30. Microwaves are emitted from two sources at points x and y. The two waves meet at points z. The diagram shows the paths of the two waves. The waves emitted from points x and y are coherent. What does coherent mean? The waves have constant phase difference. Okay, there is constant phase difference between the two waves. So constant phase difference, these are the keywords. So that is my answer, 30B. What is the unit of resistivity? We know that R is equal to rho L by A. So rho is equal to RA by L, which is ohm into meter square by meter. So ohm meters, 31 is D. Okay, 32. A kettle is connected to a 250 volt main supply. What are the possible values for the power of the kettle and the current in the kettle? Okay, we know that P is equal to IV, right? So 500 is equal to 0.5 into 250. Is that legit? 0.5 into 250 is 125. So as you can see, it's 125, which is wrong. So let's go to the next one. 500 is equal to 5 times 250. That is also wrong, because it's 1250. Let's go to C. 2500 is equal to, I'm just using this formula, 0.1 times 250, which is 25. It's supposed to be no, it doesn't match, it's not equal. Let's do D. 2500 is equal to 10 times 250, which is correct, 2500. So I'm going to go with D. I told you trial and error answers tend to be D. Which circuit results in output voltage increasing with increasing temperature? So this is a thermistor. We know that what happens with the thermistor, when temperature increases, resistance actually decreases. Okay, so A is completely wrong because it's connected to both. It's not right. Let's look at this. Increasing temperature, when temp increases, resistance will decrease. So according to potential divider, its voltage output will decrease. So B is wrong. Let's check this out. When temp increases, resistance decreases. So the voltage of the thermistor will decrease, but the voltage of the fixed resistor will actually increase. So 33 is C. Great. 34. 4 resistors, each of resistance R are connected as shown. So basically these three are in series, so that's 3R, and these three are in parallel with this one. So essentially we know that for parallel, 1 by 3R plus 1 by R reciprocal is equal to 120. They mentioned that. So let's do this. 3R, so 1 plus 3 reciprocal equals to 120, or 3R by 4 equals to 120. So 4 into 120 by 3, that gives us a value of 160 ohms. So 34 is C. Yes. A cell with internal resistance is connected to a variable resistor R as shown. The resistance R is gradually decreased. R is decreased. How do current and terminal PD actually change across the cell change? So resistance decreases. So what will happen to the total current? We know that total current will increase because when resistance decreases, current increases. But the lost volts, okay, the lost volts will increase due to the increased current because lost volts is equal to IR. So lost volts increases. And what does the terminal PD mean? It is the potential difference that's available for the components outside the battery. It's basically the EMF minus the lost volts. That's the terminal PD, okay? So EMF is constant, but lost volts increases. So what happens to terminal PD? Terminal PD must decrease. This is a scenario that you must be familiar with. If the external resistance decreases, current will increase, okay, but lost volts increases, so terminal PD decreases. 36. The diagram shows a circuit with cell and 3 resistors with resistance R1, R2, and R3. The cell has negligible internal resistance. The total resistance is RT. Which equation is correct? Okay, so it's R1 plus R2 on top, and here it's parallel with this. So it's actually going to be 1 divided by R1 plus R2 plus 1 divided by R3 and reciprocal of this. Okay, that's the total resistance. So let's try doing this. Oh, okay, you can also keep it like this. This is equal to 1 by RT. Do we have this? Let's check if we have this. 1 by RT is equal to 1 by R3 plus 1 by R1 plus R2 because these two are in series. Yes, we do have that. So 36 is D. Last 4, hydrogen and deuterium can be represented by these nuclide symbols. What is the difference between hydrogen and deuterium? It's the same. They are isotopes of each other. They have the same proton number, but deuterium has one more neutron. Okay, both deuterium has one more neutron. So let's check that. The deuterium atom has twice the number of electrons. Wrong. They have the same number of electrons, which is 1. The deuterium nucleus has a charge, but the hydrogen nucleus has no. Both have a charge of +1. The deuterium nucleus has less mass. Wrong. It has more mass. The deuterium nucleus has half the charge per unit mass. This is true because this one's charge per unit mass is 1 by 1 and this one's charge per unit mass is 1 by 2. So D is the correct answer. 38. A radioactive sample decays by emitting beta minus particles. The energy released in the decay process is the same for each nucleus that decays, but the beta minus particles emitted have a continuous range of Ke. Why? So mainly this is due to the fact that gamma radiation is produced, which might vary, and the nuclei that are produced, the daughter products, have varying amounts of kinetic energy. And some energy is given to the antineutrino. These are the main idea. Where the energy goes, but the logic for the continuous energy, I'll tell you why. So suppose we have this, like carbon, maybe like 14,6, it decays by beta minus radiation, okay, 0 minus 1, and we get an electron antineutrino, and it turns into maybe something like, you know, nitrogen. Okay, so the logic is the energy is shared between these two particles, mainly these two. Okay, the antineutrino and beta minus particle, they share energy, so it's like a continuous range, give and take. Which particle is not a fundamental particle? So fundamental particles are quarks and leptons. This is a lepton, this is a lepton, this is a quark or fundamental particle, but a neutron is composed of 3 quarks, so it's not a fundamental particle. Where is the charge of a anti-top quark? So top quark, okay, is top is plus 2 by 3e, so anti-top should be minus 2 by 3e. Okay, so 40 is actually A. So guys, that was it. Overall, I think it was a very basic and easy paper. I didn't find any questions hard, honestly. All of them are doable, common questions. So yeah, thank you for tuning in. Hopefully I could clear your confusions. If you have any other requests, please drop down comments below. Remember to like the video if you think this helped you, and yeah, if you want more help, please consider joining my mock and revision batches starting from February 2025. I'll also be doing an iPhone 16 giveaway hopefully at the end of this month, so look forward to that for my subscribers only. I'll drop a link for the form in the description box and the comments. And also quick shout out to my top tier patron for the month, Nigel. If you guys want to, one-on-one video meetings with me where we can, solve your confusions, please do consider supporting him on Patreon as well. I'll drop a link for that as well. And yeah, that's been it. I'll drop a link for May-June 2024 paper 1-2 up here, and the link for May-June 2024 paper 1-3 down here, and the playlist for physics paper 1 up here. And remember to hit the subscribe button. See you guys. Bye bye. Take care.